Hey everyone, nice to see at least a few people to have a look at this talk. It's about basically oxidizing parts of the Arch Linux packaging infrastructure. I'll try to give like a short overview of what I'm about to talk about. So, well, a bit of background info and, well, the motivational part and of course the oxidation, very important, and where we can lead this further from here. So, a little bit about me. I'm a freelance software developer. I have been doing work on Arch Linux for quite some years now, mainly as a package maintainer for various packets. It's like all across basically, from Pro Audio to Python, Rust, desktop applications, you name it. It's really all over the place by now. I have also been a developer, which is some sort of like in-between state of, the higher role at Arch, you could say. It doesn't really have like a clearly specified, term, I guess. And I've also been a main signing key, which is basically part of, the Arch Linux keyring that we use for signing all the packages or verifying that the packages are signed. My main interest is basically, packaging, of course, but also, writing software myself. I'm a Python developer, but also Rust developer. I'm quite interested in the installation process. I did a big revamp on Make Arch ISO and so on, so the installation medium. And I'm also trying to get my hands a bit into the infrastructure in general with, that is related with Arch, or that we run ourselves. So yeah, the obvious obligations here. Who in the room is using Arch or has used Arch? Okay, that's basically most, I would say, or like 90% probably. Nonetheless, I guess we need to dive into at least some background info. First of all, of course, Pacman, the Pacman project. It has the Pacman package manager that's written in C, and it also comprises of the make PKG tool that we use to build our packages. It's written in Bash. So going a bit deeper into like what is distribution packaging, what that actually means for Arch is that we have a PKG build file that is the script that basically builds the package that you use with make PKG. We have dev tools, that is like a set of tools that sort of wrap around make PKG and other tools to ensure that you're building in a clean CH root. Which in this case means, if you don't know what that means, is that you're building in an environment that only uses the packages that the package requires to build and or to run. So that, these are also locked packages basically, or versions of packages in there. But we'll get to that in a bit. And there's also DB scripts that's sort of related to the entire ecosystem. We use that for basically the repository management. So the packages that as a user you synchronize with and download from, they are managed using DB scripts. That's a quite old set of Bash scripts as well. There's the notion of the user repositories. The biggest feature, I guess, or one of the biggest features of Arch is arguably the AUR, the Arch user repository. And as is, it doesn't really provide you with a package. It provides you with a build script to build the package and then install it. And anyone can upload build scripts there, basically. We have also the possibility to integrate unofficial user repositories. Those are actual binary repositories, so pre-built package files basically that you then manage yourself in a predefined directory structure that Pacman understands how to use and how to download and install from. And there's a plethora of AUR helpers that a bunch of people over the years wrote that integrate with the AUR to automate like updates of packages or package build scripts basically that are present in the AUR, so you can update them, install them, etc. So yeah, that begs the question: what is the package actually? You know, and very simply put, it's really just a tar file, and that's mostly the case, I would say, for all the distributions that I'm aware of. There are some fringe ones that deal with image-based approaches, but that's kind of not really what we're doing here. Yeah, it contains files that are to be installed on the target system, of course, and it contains files that describe the metadata of the package, and that's what the meat of this entire talk is about, actually. And we also have scripts that run, like post-action scripts, etc., that do things after you've installed the packages or before you install the packages, which run as root and are kind of not so pretty, I guess. So getting to the metadata of the package, we have the build info script that describes the build environment of the package. So when you use make pkg to build a package, the build info file will basically contain the information of the entire environment that you build in. If that is your user system, that will potentially be quite a lot of metadata in there. If you build in a clean CH root, then you ideally only have the package and infos in there that are basically used to really build and use the package. We have an M-tree file as well that describes package contents. So that is kind of, yeah, it's basically just a libarchive M-tree file. If you're interested, there's a link also later on. You can check it out in more detail. It's basically like a descriptive, quite descriptive file to describe files and also directories and their file modes, their ownerships, etc., in a very comprehensive way, which is then later on used by the package manager. We do have the pkg info file, which is the literal package metadata, such as the name, the version, all of this stuff, the dependency declarations and all of this. And a bit on the outskirts of all of this is the source info file. This describes the relationship of the sources of the package. So when you build the package with a pkg build file, you can also generate a source info file from it that will describe, for instance, what is the tarball that I downloaded, what is the hash sum of that tarball that I downloaded, etc. This is mainly used to not have to, oh shit, I'm sorry. I should probably prevent it from doing that, that's good. It's basically mainly used for not having to parse bash as is, right? That's kind of terrible. You don't want to do that on a web server, for instance. It's not so pretty. So we have some nice examples. Let's look at that standard, for instance. This is how build info would look like. It tells you like where stuff is being built, where the start year of the command is that built the thing, which version of DevTools was used, which is our like default build tooling, and then it lists all the packages that were present while building the package and in their specific versions, etc. The M-tree file is, as I said, like a libarchive M-tree file, basically. So this is the extracted .m-tree file, and has like a quite funky declarative way of overwriting modes, etc. So you can be very brief in declaring like what is the mode, what is the ownership of files, and even if they change, it's easy to declare that. We have a .pkg info example here, of course, as well. A lot of this stuff is basically found in, where's my mouse? Finding the mouse is a challenge here. Here. If you know what a pkg build file looks like, then you will recognize most of these fields. They're basically taken from there. And then there's a source info example of the same file. And here you can see, for instance, the checksums and so on of the files that we downloaded. So, yeah, coming from the packages, we actually have to also talk a bit about like what is a package repository. And usually that, in our case, is a bit of a legacy thing to some degree, but mainly it is an architecture-specific directory structure. And we have, well, the packages, of course, we have signatures for the packages in there, and we have sync databases, and we get to those in a bit, that describe the repository. And the package manager is basically the tool that, from the user system side, interfaces with those repositories. And it's easily exposable by just a web server, so it's very just a file tree, it's easy peasy. Yeah, Pacman downloads, synchronizes the stuff for its local state comparison. And yeah, if you want to have a look like what this looks like from the inside, we have like a symlink farm sort of that leads to like huge pool directories. This has the upside of very easily and very fastly switching between directories also. So if you want to move a file, let's say from the repository called repo, in this case, you would easily just move a symlink and that's it, or create a new symlink. And you don't have to do any like huge file operation, which would take potentially very long. Yeah. So, as said, we have the sync databases that describe the repository itself, and this is sort of like an index, right, that describes what is in the repository and holds the source of truth, even if there are other files present. So you could add additional files in that repository directory. Pacman on the user side would not be aware of them because it only looks at the sync database. Yeah, we have, unfortunately or fortunately, we have two of them, or two types. One is plain metadata and one is metadata plus file info. And file info in this case is the ability to list the files, the contents of packages in a repository using that particular database file. We can have detached signatures, but unfortunately we don't because we do not have a signing enclave yet. But that is being worked on at the moment. Yeah, exactly. And Pacman, as said, uses these to install the packages from a repository. As I mentioned earlier, we have two different types, and we have the default sync database and the files sync database. And the only difference is that the files sync database has an additional files file per package, and the desk file is also basically a superset of the pkg info file with additional fields, and the files, you could say, is a very slimmed down version of the mtree file, sort of. Yeah, it's very particular to the version of the package that you have in that repository. There's only ever one of a given package in there, in the specific version. Same for the files file. And as I said, it's kind of a superset of the .pkg info file. It is quite, oops, sorry, that was a bit too fast. It is basically, yeah, just based on some identifiers that specify specific fields. We even have an encoded signature of this package in there, so you can still, at the given time, verify even against the database when you have downloaded the package file and the signature of the package. And the file is super basic. Basically, it just has one identifier and then a list of files and directories. So to kind of sum it up, we have like these relationships between the various files. And mainly for package building, we have DevTools and MakePKG. That basically hands off to repository management tooling, in our case DB scripts. And then we, on the user side, are able to use an interface with the repository using Pacman, the package management software. There's like an overview here. We can also skip through that because this one is a bit more interesting and probably dense. As you see, we have lots of like creation of files in the context of the package repository management software that has to create these sync databases, and we derive all of this information from the files that we consume, which in this case are packages and signatures. And at the same time, we also have to verify against .source info files. This is something, for instance, at the time of writing is not implemented. But this is usually good practice because then you can also verify against your source upstream. On the user machine, we have a similar set, by the way, in regards to desk and files. Pacman itself has a state directory in which it manages what it basically currently contains as state on the system, also in desk files and files, and describes in this way how the system can be upgraded from one state to the next. The problem here is these files are different. So the files file is the same as the one you would find in a sync database, but the desk file is not. It has additional fields, which is slightly confusing because they're called the same, of course. Yeah, this is basically a sum up of what these images contain before. We have package files and so on that contain all this metadata, and it needs to be consumed and further on like manipulated into other files, etc. down the road. So you might ask yourself, like, what is the motivation of this entire thing? Why am I talking about Rust in this context? What is the entire thing about? I mean, quite obviously, Arch Linux is quite old. We are now like 20 years old by now, actually, and same as is the package management ecosystem that we have. As you can imagine, we accumulated quite a lot of complexity and legacy stuff over the years. We have a bunch of closed loops in this case also, because Pacman is, in a way, the thing, or the Pacman project is the thing that defines how to build packages and what packages contain, but at the same time it is also defining how to consume the packages. The problem is that all intermediate software, such as repository management software, is kind of left out of this loop, if you get what I mean. This is particularly problematic with changes to the internal files. We basically create them in MakePKG in Bash, and there's no specification. That is kind of terrible. As you can imagine, when you have a Pacman release, you may or may not break things because of that. If you change things, if you're not very, very careful, you might break how these files basically are consumed or work or are being treated by other software that is not aware of this potentially. Most of these files do not have any specification. So you could say it's a floating spec. We have one file that actually does. This is a build info. It has a format version, sort of. But it's not necessarily super clear what that means. And like change from one or the next is not really clear to anyone outside of the Pacman project, I would say. As you can imagine, the specification is hard on its own, but validating all of this is even harder if you don't really know what you're validating against. We don't really have unit tests for this. And well, yeah, that makes basically the repository management very, very hardcore and limiting, because this is all bash based, and then in that scenario you sort of can kind of integrate with things, but I mean you need to actually have something that can do things with transactions and concurrently without breaking things, because we do have issues with moving larger sets of packages from one to the other repository, for instance, and if that is not properly locked, it might break your database, and then you need to rebuild your database, and that's not so much fun, because that means that all the sync servers will sync some trash in the meantime, and that's not so much fun. Yeah, there's not much input validation either. So this is Vercomp, our version comparison tool that is shipped with Pacman. And well, it doesn't really do proper input validation, I would say. And to our excuse, we stole most of it from RPM. So it's well, it's still something that is quite old by now, as you can imagine. Most of this is written in C, and this is before the time of funny emojis in in files, I guess. Well, to jump to sort of a different topic in regards to the motivational factor here. I mean, apart from all of this being quite old and having not so many specifications, I spent quite some time building a tool called RepoD that is supposed to eventually replace DB scripts because we wanted something that is more unit testable and at the same time well, written in a language that you can actually sort of reason about, but at the same time, yeah, trying to improve on the given workflows and having transactions. This is currently fully validating using pydantic models, but that also means it's Python. It generates sync databases already via an intermediate JSON file format. So our idea is to basically have an intermediate format that we can also dump as proper state and always derive a sync database from at any point in time. You can already inspect package files and repositories using the RepoD file tool, but as is, this is also still kind of in its infancy, and there's still a lot of features missing. Yeah, so writing all of this was kind of educational for me, but at the same time also very frustrating, but that's because, well, there's no specification for any of these files proper, so I needed to rewrite or write actual parsers and specs in the context of RepoD for all of this, and well, now I have two problems, right? So that's not so much fun. Yeah, that leads to a lot of additional code that I actually don't want to maintain. We have issues also in regards to compatibility, not only in Python land, but all across languages, actually. We do have libALPM, which offers integration from the C side of things. It's also the library that Pacman uses under the hood to basically maintain state of a user system, to download packages, validate packages, or verify, not validate, and then install and uninstall and all of these actions basically. But that doesn't mean that any of the in-between steps are really taken care of. You won't have any validation of any of these additional files, right, because of that. That led to a bunch of edge case and fringe implementations of everything, basically, in all languages, with source info parsers in Python and Rust. And due to not having any specs that are really strictly enforced, we also have issues in package metadata, basically, because of that. RepoD being already sort of strict on this can enforce this while consuming packages, but as it is not in use yet, dbscript is still what we use for managing our repositories. This only can validate after the fact, basically. It can consume an entire repository and then go over the files and see, oh, this actually has broken metadata here. You should not use this string in, I don't know, the package name or something like that. And ideally, of course, you want to have that when you create the package and not when you later on consume it. Hence, we come to the oxidation part. And so, yeah, as you can imagine, we're in dire need of specs, and we also want file parsers and writers. And we want to integrate them across all languages, ideally, of course, and have them come from the same source. And we want memory safety and speed because it's 2023. Why would you not want that? That's why I started ALPM types this year, which is more like a centric crate to have common types that are used all across the stack, and started implementing low-level types that are already useful on their own, and while looking at specific specifications for files. One goodie is we can already have, actually from that quite trivially, we could have a vercomp command that is more strict and can, well, distinguish cats from dogs by just failing. And I've also started ALPM build info, which is a library and binary crate that is supposed to basically hold the specifications for the .build info files. My idea here is to have like man pages per file version and have a very strict set of rules that apply to each file version, and to be able to create them also using a command line tool. And currently we were pre 0.1, which would allow us to describe version 1. We're actually at version 2 already with the build info files, but that's where we are at currently. So yeah, going further, we have a bunch of tasks ahead, as you can imagine. There's a lot of stuff to be done. We not only want specs for build info, we want them for pkg info, M3, source info, and we need to add all of these potentially extra types that are used across the stack or to ALPM types. And we also want desk files and files specifications, because eventually we would like to reuse this entire stack also on the side of creating repository sync databases, right? This leads us to, well, obviously upstreaming all of this eventually into make pkg and repo add, because that's the baseline tooling that we have currently to replace these reference or floating spec implementations that we have in make pkg, and then start to export for other languages and provide integrations for instance, for Python. So we can get rid of all these extras in RepoD and obviously profit. But yeah, you might have asked yourself like, wow, what's that's kind of nice, but would you want to go further than that? Because I mean, just having specifications is nice and all, but there's potentially more to be done, and I would tend to agree, because there are not only the sync database descriptor files, but also the libALPM descriptor files that we have on the user system side, and they need specifications as well. And while we're at it, why not implement libALPM in Rust eventually? Because that would actually make sense. And dreaming up a rackman, right? The question here is, of course, I mean, when is that feasible to happen? And I agree that this needs a lot of work. Hence, I come to the potential funding of all of this. I am not sure if you're aware of this, but Arch Linux is basically entirely community driven, and this means that there's no affiliation with any like company that backs this entire thing and or spends money on infrastructure or whatever. This is all donation backed, and most of our donations actually go into community events or our own infrastructure hosting. In this case, all developers that are working on any of this, and also the packages are unpaid. So if any of you are interested and or have like some change, no, I'm joking, but this is of course like a larger endeavor, and means it needs some more substantial funding. And if you are affiliated with a company that is interested, for instance, in funding any of this, please reach out. You can find all my contacts here. And, well, the current state of the ALPM projects, of course. And in any other way, you can also reach out on ISC or the mailing lists with us. Are there any questions?
So, for version comparisons, the API code doesn't spec for comparing versions.
Oh, wait a sec.
Sorry.
I think your mic is not working yet.
So for versions, there is a spec in the UAPI group to do version comparisons, so it might make sense to make sure that for the new vercomp implements that spec. Since it's the UAPI one is based on the RPM version comparisons as well, so I assume that they're already mostly compatible. But
yeah.
The only thing is I'm pretty sure it just ignores any Unicode characters, so I don't think you'll get an error if you start comparing dogs and cats.
Yeah. I hope so. Yeah, I totally agree. I mean, there are some things we need to keep in mind while going forward, but at this stage we're currently mainly trying to move away or replace existing tooling, which means that we need to be fully compatible with that. And but yeah, we definitely need to keep that in mind, and it's a good hint. I'll definitely reach out after the talk.
Is there a meaningful way that people can get into this project and contribute in other ways than money, like actual dev work?
Oh yes, yeah. I mean, this is an open source project, so you can create an account and with our GitLab instance and start contributing right away if you want to. Not all of it is super planned out, so it might make sense to first reach out on IRC or mail or whatever to figure out like what's the current status of the things, because at this point I'm the sole person working on this like mainly, and there are two other people that are kind of interested but also freelance people, so it's not so easy time-wise to really allocate proper time for all of this.
Hello, thank you for the talk. I have two questions, very short ones. First is, have you considered making a campaign yourself for funding, like Buy Me a Coffee or PayPal, where people can contribute, like to post it on your GitLab, just for people to do this? And the second one, have you considered attracting more contributors through Google Summer of Code or GNOME Outreach program? Thank you.
I have done neither, although I'm able to receive funding via GitHub. The thing is that I think this is kind of problematic to kind of fit into Google Summer of Code project, in my opinion, at least, because it's kind of very specific domain knowledge, some of it at least, and you need to really dig into some of the concepts. And if you're not a Rust programmer, you might have a hard time getting into that. And I'm not entirely sure I'd be up for mentoring that, but I definitely consider it. Yeah. Other than that, we have tried getting funding via various means already. It's like NLNet and STF, but those are kind of hard to get, I have the feeling, due to their own like constraints in regards to what they actually want. Oh, some mic did something.
Turn my camera off and this.
Oof. Evil camera. Any more questions?
All right, thank you.
Thanks a lot.